So on the previous lesson, I gave you a homework. Did you try to attempt the questions?
Yes, I did.
Okay, 100%. Let's quickly discuss your answers and then we'll take it from there.
Okay.
Okay, so now let's look at this question. Okay, I think the first homework was on this table, ne?
Yes.
Okay, the first homework was on this table. We were given a balanced equation and we need to use this balanced equation to complete the table by counting how much atom in each side of the equation do we have. Let's look at the bromine. That was your homework. You need to
Yes.
count the number of reactants. Before we do that, let me quickly remind you what we did last time. We
Okay.
said when we look at N from this balanced equation,
Mm-hmm.
okay, so on this balanced equation, we look at N, which is nitrogen. We count how many do we have in reactants. So this is the 2 for N in reactants, means that we have 2. That's why our answer is 2. Then we do the same for the product. So the N has 2 also on the product. That's why our answer was 2. So now tell me,
Yes.
what did you get for the bromide? What is your answer for bromide?
It was 2 for the reactant and 2 for the products.
Okay, you also got 2 for the reactants and 2 for the products. Well done.
Yeah.
I'm very happy with the answer. Let's move. So when we go
Okay.
down on our previous lesson, we also had a homework where you need to balance the equation.
Mm-hmm.
Now let me quickly check. Okay, so on this one, you were supposed to balance the equation Ca plus O2 and
Yes.
CO2, then the other one is nitrogen that reacts with hydrogen to form nitrate. Okay, so now we're going to discuss what your answer was supposed to be on this one, how you were supposed to balance this chemical reaction. Let's quickly work on this one. Okay,
Okay.
so we first have calcium for the first
Mm-hmm.
one. So we first has calcium. So I'm going to first explain this, then you'll tell me if you have the same answer, okay?
Okay.
Perfect. So at first we have Ca. The Ca, it reacts with the O2, right? So now these are our reactants and this forms CaO. So when I look at this,
Mm-hmm.
carbon, I mean calcium, there's one on the reactants. There's
Yes.
also one on the product, and we can confirm and say this is balanced, right?
Yes.
For calcium, but for oxygen, there's 2 in the reactants, meaning that if there's only one in the product, we need to put 2 in front of that molecule.
Yes.
Now this changes the number of molecules in for calcium. So now this tells you that for the product, how many do we have for Ca? There are 2,
2.
meaning we need to put 2 in front of that one to
Mm-hmm.
get what? To get for the calcium on the reactant. Do you understand?
Yes.
Then now the reaction is balanced.
Yes.
So tell me, what was your answer for this one?
Um, I got N2 plus 3H2 is equal to 2NH3.
You got 3H2.
Yes.
Then this is
2
equals to
2NH3.
2NH3. So there's 2 nitrogen atoms, and then there's 2 on the product for nitrogen, balanced. There's 6 hydrogen atoms and also 6, then this one for hydrogen, balanced. Well done. Thank you very much. And then now in an exam, you have 2 marks, okay?
Yes.
Well done. That's very good. Very, very good. Né? So then when we keep going, we talked about turning the following chemical equation into pictures. And also I gave you a homework on this one. I'm not sure how I can see your picture, but I'm not sure. Are you able to show me on the camera or something? I don't know.
I don't know. I can try.
Or maybe I can just
Okay. So I got, what was it? Oh, I think it will be easier to show you.
okay, so that is very, very correct. So I'm not going to waste time to do the drawings now.
Okay.
Yeah, but I'll definitely give you the memo if you want. It's fine. Okay, I'm just gonna, since you understand how to do the balancing, let me skip this one and go into what we're gonna work on today, okay?
Okay.
Okay, so I'm just gonna leave this one. You see, I have prepared something for you by the end of reaction. But no, we're not going to do any reaction. By the end of this session, I'm going to explain each and every picture that you see here. You
Okay.
understand? All these pictures, I need to explain to you what is going on these pictures, and we'll try and take this step by step, okay?
Okay.
All right. Okay, so now, before we even start about that one, there are some of the key information that I need us to review. Also very important, yeah?
Yes.
Let me quickly, okay. So this is very, 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 very important. Just give me a second. Let us just go back to chemical reaction.
Okay.
Okay, so we talked about chemical reaction. Do you still remember what is chemical reaction?
Let me just see. I think I know.
Okay. If you still remember previously, I said I'm looking for two words when you say chemical reaction. What are those two words?
Is that the reactants and the product?
Exactly. The substances can combine with each other during a chemical reaction to form products with different chemical properties. So in chemical reaction, we have what we call Wade equation. So they will need you to write something in Wade. Sorry, we have Wade equation. So when I say Wade equation, these are reactions that we can express them in weights. Are you following?
Yes.
Okay, so if I say give me Wales reaction for hydrogen and oxygen, we know that you're going to write hydrogen, and then you will tell us that the hydrogen reacts with what? It reacts with oxygen. And what is the product? We use an arrow to write the product. So this will give us water. And if I say give me a chemical equation, so if I say give me a chemical equation, so you're going to say hydrogen, it's a diatomic atom, which is H2. It will react with oxygen, which is also a diatomic atom, that's H2. Then this gives us what? This gives us H2O. I know the equation is not like balanced or stuff, but we're not doing that now. What I need you to understand, in an exam, they can give you a chemical equation and they need you to write it in what? Weight equation. Or they can give you a weight equation and they'll need you to write it in chemical equation.
Okay. So
All
it does
good.
not matter if the oxygen has no two.
If
On the H2O, the oxygen doesn't have to have two.
you mean like this one?
Yeah.
No, you don't. We don't have. We know that if hydrogen react with oxygen, we get water. But the moment you put the 2 there, the subscript 2 is no longer water, you understand?
Okay.
But what you can do, you can balance this equation.
Okay.
You get it?
Yes.
Right. So if we balance the equation, maybe we can just try and put the 2 in front. If we put the 2, this tells us that for oxygen, it's balanced. Then now hydrogen, we have 4 of them. Then
Yes.
we need to put 2. Then this equation is balanced.
Okay.
You get it, right?
Yes.
Okay. So now, I think I need, let's use this guy here. Yeah, maybe this will work. Okay, let's do this. Now, in chemical equation, these are the important properties of chemical equation, because if I don't explain this, we're still going to have an issue. So the first one is an arrow. You can see that most of the time when we write chemical equations, we use an arrow like this, okay? So this arrow, we use it to separate the reactants from the product. So this, it separates the reactants and what? The reactants, they will be left side of the equation, from, it separates the reactants from the products, and products will be on the right side of the equation. I hope you understand that part, okay?
Yes.
Okay, so left of the arrow, if I put an arrow like this, just know that on the left of the arrow, everything present before the reaction are your reactants, and right of the arrow, everything present after the reaction will be your products. You understand?
Yes.
Right. This is the first rule when it comes to the properties of chemical reaction. The second one, which is also important, it's what we call, you say, no new atoms are created. I'll definitely explain this. No new atoms are created. When I say no new atoms are created, it means that only atoms that are present on the left of the arrow may be present on the right of the arrow. We just, we had one example now. What was that example? We had an example now where we talk about hydrogen. It reacts with oxygen to give us H2O. Look at this. On
Yes.
the reactants, we have H, and also on the product, we still have H. We have O and we have O. We don't have Cl. You see, since there's no Cl in the reactants, you don't have to have something that you don't have on your reactants. So what I'm saying is that, I'm listening. You have a question?
No, I don't. It's fine.
Okay. So only atoms that are present left of the arrow may be present right of the arrow. So if there was no Cl in the reactants, then there can't be Cl in the products.
Okay.
You understand?
Yes.
Okay. And that's what I wanted us to talk about, okay?
Okay.
All right. Now let's go to what we're going to work on today, which is, let's go back this side. Okay. So now let's look at this topic 2, common chemical reaction. So let's first start with reaction of metals with oxygen. So we're going to take a metal. So the one that I'm going to start with, this one, it's a common one. It's a common equation. So we're going to take a metal, and then let's take that metal and react with oxygen. Okay, so when you take a metal and react it with oxygen, since it's only one oxygen, you'll get metal oxide.
Okay.
Right. So now, what is going on if you look at this picture? Can you see the picture?
Yes.
Okay. So now, if you look at the picture, we have a metal that is bent. So it is bent in flame. This is called combustion, combustion reaction. Do you understand?
Yes.
So we have a metal that is bent. We're going to call it combustion. Combustion reaction. So in an exam, they'll say that a metal is bent in flame. What is that reaction called? Should I write this down for you?
Yes, please.
Because I'm going to give you the notes now. So combustion, we say the metal is bent in flame.
Yes.
This is what we call combustion. So I'll give you an example. So on an example, let's say we take iron.
Mm-hmm.
That's not the spelling of iron. Okay, let's say we take an iron and we're going to react an iron with oxygen. Remember, an iron is a metal, right?
Yes.
And then we get iron oxide. Iron oxide. So now iron, that's Fe.
Mm-hmm.
It reacts with oxygen, which is a diatomic, and they give us what? Fe2O3. So iron oxide is always Fe2O3. So
Okay.
now, when you look at this first picture, now, if you look at this first picture, can you see that? I'm not sure if you can, if you look at the picture here, can you note that the iron, which is the steel wool, the iron, we can see that the iron, it glows red in flames. In flame, can you see that?
Yeah.
Okay, so it glows red in a flame. That is what is happening. You understand what is going on the first picture?
Yes.
100%. Let's move to the next one. Let's look at what we have here. So on this one, you're going to have magnesium.
Mm-hmm.
Okay, so magnesium, it will react with oxygen, and then they'll give us magnesium oxide. So this will be magnesium oxide. Okay, so now when we write the equation, the magnesium, that's Mg, it reacts with oxygen, which is O2. They give us magnesium oxide is just MgO. That's your magnesium oxide. Then if we note that, you just have to write what, you know what, I'm preparing you for practical, because in grade 9, they can ask you this in a practical question.
Yes. Yes.
Yeah.
They
So
usually ask us this, and they ask like, what does the metal look like? Or like, what if they're burning?
nice. So you can see that if you understand all what is going on in all these pictures, most of the practicals that
Yes.
you'll do, they'll be very easy for you. You understand?
Yes.
So now we just have to explain what you see on the second picture. So this one, it makes what? It makes a bright white flame. It makes a bright white flame. That's the first thing we know. But now, do you know that magnesium oxide, it's a white powder? Do you know that?
Yes.
Yeah, so magnesium, it's a white powder. It's a white powder. So once we burn this thing, and then we're going to get a white powder as the product. To understand, if you take magnesium and react it with oxygen, you're gonna get a white powder.
Okay.
Okay. Let me move to the next one. The next one, if you look at this has to do with copper reacting with oxygen. They give us copper. I said, I'm good, thanks, Anu. Okay, so if a copper react with oxygen, they give us copper. So this is like they give us copper oxide. Sorry,
Okay.
copper oxide. Then copper, that's Cu, it react with oxygen. And what do we get? So this gives us copper oxide. So now, this one, if we note down what is going on here, we can see that it makes a green flame. That's the first thing that we note.
Okay.
It makes a green flame. Okay, that's the first thing. The second thing that you need to note is that copper oxide is a black powder. So now, listen, when they say you need to study smart, not hard, né?
Yes.
In an exam, they might say, what is the difference between magnesium oxide and copper oxide? Then you need to write this statement and say, magnesium, it's a white powder, copper, it's a black powder. So they'll say, what is the difference between magnesium oxide and copper oxide? So the difference is that magnesium is a white powder, copper is a black powder.
Okay.
Okay, so now there's a question there, not exactly a question, but just a statement. Okay, but before I move, do you have any question on this one?
No, I think it's fine.
All good, 100%. Okay, so now we have a rust. It happens, a rust, if you look at this, a rust, it happens when ion containing substances, it react with oxygen in the presence of water. Okay?
Okay.
So now, a rust happens when an ion react with oxygen. Then you put an arrow. I'm coming back to that. They give us iron oxide. So now, if we go back up, let's look at up. If we go back up, at first we had what? An ion that react with oxygen to form iron oxide. Can you see that?
Yes.
Now we come back and say the iron plus oxygen, they give us iron oxide. The difference is that this one has a condition. You understand?
Yes.
For a rust to happen, there should be water. So on top of this arrow, you write water. Whatever that you write on top of the arrow is the condition, is the reaction condition.
Okay.
Are you following?
Yes.
Okay, please give me a second. Appreciate you
You're welcome.
for waiting for me.
So I have a question.
Okay.
Is iron oxide like another name for iron oxide rust?
No. It's the same one. Thank you. So it's the same, like, you mean how we write the formula, right?
Yes.
Remember at top we said this is Fe2O3. It's the same as this one. It's the same as this one. The difference is that this one has a reaction condition, so it needs the presence of water. So this will be ion with oxygen. So they'll give us what? They give us iron oxide, but this one needs a what? It needs the we need to have what we call water to be present in order for the rust to happen. So now they will need you to explain what is a rust. So this reaction, it forms what we call, it forms a flaky orange. It's orange brown layer. orange brown layer, as you can see from this picture. Can you see that?
Yes.
Oh, we keep moving. We keep moving. Okay, so this one is what we call, how can we prevent rust? There are ways that we can prevent rust. Maybe you can give me one by looking at what is going on this picture. So this picture, it gives us the ways that we can do to prevent rust. Tell me.
Yes.
What?
So don't you like paint like the bars usually with a special paint to prevent the rusting?
Exactly. That's excellent. 100%. So now, in an exam, they will say, give us the ways to prevent what we call a rust. Okay, so the ways, number one, we can cover with paint. We can cover with paint. If you don't want to say that, we can use lubricants. Or we can just use oil. Understand?
Okay.
Right. Number two, it's what we call another way to prevent rust, it's electroplating. Right, I'll explain what is electroplating. So you'll see when you get to grade 12, you'll understand more about electroplating. You will even hate this topic when it comes to electrolysis. So we're going to use using electrolysis to cover ion. I keep getting this one wrong. Okay, we use electrolysis to cover ion with a layer.
Okay.
Okay, with a layer of metal, a layer of metal that is less reactive. Right. For example, we can use chrome. Okay, let's give example. We can use chrome, and that's Cr, or you can definitely use aluminum. Can aluminum get a rust?
No.
No. So that's what we can use to prevent rust. And then another one that I can give you is what we call, let me give you the last one. This is galvanization. We can use galvanization. So this one, when I say galvanization, I'm referring to, you're going to cover the ion with what? The ion with a layer of zinc, with a layer of zinc. Don't worry, after this lesson, I'm sending this your way, okay?
Okay.
Which should be less reactive. Less reactive. Can we move now?
Yes.
Okay. Don't worry, you can review the notes when we're done. When you receive the notes, you can definitely review them, okay?
Okay.
So now, let's look at the next part. So the first part, this first one, if you can read here, it says number 1. All this that we're doing, it was the reaction of metals with oxygen, okay?
Okay.
So now, what about the reaction of non-metals with oxygen? We're going to react reaction of with oxygen. Okay, let's start with the common reaction. The common reaction, we're going to take a non-metal. This one is a common reaction. A non-metal, it will react with oxygen, and they'll give us non-metal oxide. So they'll give us non-metal oxide. So if we look at this picture, if you look at this picture, I think you can see that we have a carbon. It reacts with oxygen. Carbon is a non-metal, and then it reacts with oxygen, and therefore, what do we get? Carbon dioxide. Carbon dioxide. So if, please, you know, we are not playing here, né? It can feel like we are playing, but you'll see when you do past paper question, you'll see that we are collecting a lot of marks. So I need you to pay attention on this, né? Carbon.
Yes.
And then we have oxygen, and then it gives us what? Carbon dioxide. So in an exam, you know what they're going to do? They will say that in which state it's carbon when it reacts with oxygen, or they'll say this is a reaction of non-metal with oxygen. What state is carbon? You just have to know that this is in solid state. And what state is your oxygen? It's in gas state. And what state is the carbon dioxide? It's in gas state. So if you understand this one, and then you'll definitely collect the marks. Then when you look at this picture here, what do you see? We see a carbon, which can be referred to as a coal. It makes a yellow flame. So every time I see a yellow flame, I know that's carbon.
Okay.
Okay. Right, let's move. Look at how nice this picture is.
Yes.
It's very nice. And they say, if you look at this one, this is the same, right? This will be sulfur.
Mm-hmm.
It reacts with oxygen. And then it gives us what? Sulfur dioxide. Sulfur dioxide. So sulfur, that's S, it reacts with oxygen. That's a diatomic. It gives us sulfur dioxide, that's SO2. But now, it's very important that we note down the state for each and every molecule. Sulfur, it's in solid. So, and then oxygen, it's in gas state. And then sulfur dioxide is in solid state. So now, what do you see there? We can see that on the picture, the sulfur, it makes what? A purple. Someone can say, instead of saying this is a purple, someone can say it's a blue flame, okay?
Yes.
It's a blue flame. So it's either you get blue or purple.
Okay.
And look at how scary this one is.
Yes.
So this one, is this the last one? Yes, this is the last one, okay? So now, by the time we complete this one, you'll know the difference when metal reacts with oxygen and also when non-metal reacts with oxygen, okay?
Okay.
Right. So on the last one, this is phosphorus. Phosphorus, it reacts with oxygen. All of this, they react with oxygen. So this will give us phosphorus pentoxide. So it's phosphorus this is pentoxide. So now it's like saying P for phosphorus, it reacts with oxygen, which is a diatomic. It gives us what? PO. But now when I look at the equation, sometimes in most time, they'll need you to, this is an exam tip, learn to balance this, okay?
Okay.
Okay, so if you learn to balance this, look at this. There's 2 oxygen this side, okay? And phosphorus pentoxide, pent, that's 4, okay?
Okay.
So this will be 4. So this tells you that there's 4 of them. And then for oxygen is 10. So it's always like this. This is always the formula. So you just have to balance the other side. So if there's 10 and this side we have 2, we just have to put 5. Then the oxygen are balanced. And if there's 4, we just have to put 4. Then everything is balanced.
Okay.
You catch my drift?
Yes.
100%. Okay, so now let's go to what we call, you see now we're going to play with some of the colors, ne?
Yes.
Let's see if we can cover this before we enter the lesson. I don't know, but now listen, before we go to playing with colors, we go to number 3. So let me go back up. The first one we talked about the reaction of metals with oxygen. Then we discussed the reactions of non-metals with oxygen. So now I need us to understand the acids, base, and pH values. Okay, so listen, a substance can either, a substance can be acidic,
Yes.
right? Basic or neutral. Okay?
Yes.
Okay, just give me a second, okay? Now we said a substance can be acidic, basic, or neutral. Right. So we're going to use a pH scale to indicate how acidic or basic a substance is. Are you still with me?
Yes.
So now this part here, pH, we use it to indicate how acidic or basic a substance is. Okay, so now it starts from 0. At 0 we have it's very acidic, and it ends at 14, and at 14 is very basic. So if it has a pH of 7, we say it's neutral, okay?
Okay.
So I'll definitely give you the list. So for acids, if it's an acid, it's going to have the pH value from what? It should be from 0 to 6.99. Then we say that this is an acid, and most acids are acidic. So if it's 0, if we have 0, this will tell you that this is most acidic. And then pH, acids, they taste sour. Okay?
Yes.
So they taste sour, and let's go and talk about the base. So the base, the pH will start from 7.1. So the pH value, they have pH value from that 7.1 all the way to 14. Okay.
Okay.
And then at 14, we say they are most basic, and then they taste bitter. Are you following?
Yes.
Okay, so now, and then they feel, it feels soapy. Okay, and that's it for this one, the difference between acids and base. Let us quickly look at how, let's quickly look at how a neutral substance is. So if we say a substance is neutral, if we say a substance is neutral, if I look at this, for neutral substance, we know what will be the pH.
7.
High five. Well done. So the pH value of exactly, it should be exactly 7. And for example, if you have pure water, it's an example of neutral substance. A pure water, that's an example of neutral substance. Okay.
Okay.
I'm just gonna quickly look at the pH scale. You'll see the pH scale. This is how it looks like. If you look at the acid that is inside your stomach, can you see that it's on 1?
Yes.
Yeah, that one is the most dangerous one. Very, very dangerous. Ne? A lemon
Yes.
juice, it's at 2. Apple at 3. You see, the more we go up, the more they are less acidic. But the
Yes.
ones that are approaching 0, they are most acidic. You understand?
Yes.
Then we set for the neutral one, the example that I gave you, it's pure water. But the more we approach 14, that's when they are most basic. At 8, it's an egg, because we said they feel soapy. And then there's baking soda, hand soap, ammonia solution, the bleach, concentrated solution of alk. You know, that one is the most one that is basic. Are you with me on that?
Yes.
Okay, so can you please read the statement for me? What is this statement here saying?
Okay. Indicators equal special chemicals used to determine the pH of substances.
Exactly. So indicators equals to special chemical used to determine the pH of substances. So I'll give you, if you can see this picture here. So let's just do example looking at the picture. Okay, so now we can see that. Let's take a litmus paper. Let's take a paper, not any paper, but so when we use this paper, that's when we can understand the pH of a substance. So just note that if this paper, it will turn red when it's what? It's acidic. And it will turn blue when it's what? Is basic. So when it's blue, just know that it's basic. And when it's red, it turns red for acidic. So we indicate this thing. You understand?
Yes.
Right. And now, okay. Let's look at this part. I just want to give you something here before we enter the lesson. So if we we talked about indicators equals to special chemical used to determine the pH of a scale. But now we have what we call universal indicators. So the universal indicators, it's equals to special. This one is equal to special indicator with unique colors. Okay, so now it with unique colors for what? For okay, let me just quickly do this. Okay, so it's I'm not sure why it keeps on doing this. Okay, so for all the pH values, okay, so now if you look at this, we have red. Let me write this down. The red, the orange, and the yellow. Can you see all these colors that are before 7? They will be acidic, okay?
Yes.
And then the green, they are neutral. So green for neutral.
Yes.
And then the last one, it's blue and purple. So blue and purple, we say they are basic.
Okay.
Okay. So now this should be the last part, but not exactly the last part. We still have more information to discuss, as you can see now. We still
Yes.
have more information. Hopefully we will manage to finish this if we have another lesson. I'm not sure,
Yes.
but if we can maybe cover the last minutes, let's cover the reaction of acids and with basic. Okay?
Okay.
I'll just leave it like that. I'll just explain the reaction of acid with basic, then we can call it a day. Then we'll continue some other time. So this is the reaction of acid with bases. Okay, so for this one, we said that a reaction is neutralization. It's neutralization reaction. We call it a neutralization reaction when when you have an acid that reacts with a base. Okay. Yeah, so we said that it's a neutralization reaction. So the pH of the product, it moves to the middle of the pH. We'll talk about that on the next one. And this reaction is used to neutralize dangerous chemical waste, okay?
Okay.
And we can use it to make fertilizers for plants. I'll definitely write this down on our upcoming lesson. Based on what we've covered today, do you have any questions?
No, it's fine.
Okay, thank you very much. I'll see you.
Okay.
I'll send you the notes now.
Thank
Okay?
you. Bye.
Bye, sharp.